look at example 3.33. So it says a canoe has a velocity of 0.4 meters per second southeast relative to the Earth. The canoe is on a river that is flowing at 0.5 meters per second east relative to the Earth. Find the velocity, magnitude, and direction of the canoe relative to the river. Okay, so whenever we're going to add vectors together, just like when we added vectors in the first unit, we're always going to want to resolve them into components. Add the x's, add the y's, then put them back together to find magnitude and direction. So this is a relative velocity problem because we have the Earth, the river, and the canoe. So we need to identify our stationary frame, our moving frame, and our object. They tell us the velocity of our object relative to our stationary frame, or the canoe relative to the Earth, is 0.4 meters per second southeast, and the velocity of the river relative to the Earth is 0.5 meters per second east, and they ask us to find the velocity of the canoe relative to the river. So the first thing we're going to want to do is resolve these into components. In other words, put them in an I hat and j hat. So southeast, so this is going to be 0.4 cosine of 45 I hat plus, and because it's southeast, it'll have a negative y component. So a negative 0.4 sine 45 j hat. This one's a little easier. There is no I hat or no j hat. It's just purely I hat. So 0.5 I hat plus 0 j hat. And this one we want to figure out magnitude and direction. But before I can find magnitude and direction, I first need to find their components and then put them back together. So that's where our equation comes in. So what we'll do with this equation is we'll make an I hat version and a j hat version of that equation. So we know this. So for our I hat version, it's going to be 0.4 cosine of 45 equals the velocity of the point relative to the moving frame, or our canoe relative to the water. That's what we're looking for. So we'll just call that v. We'll call it x, I guess, here. Plus the velocity of this one, which was 0.5. Okay. And so that should allow us to find the x component of that velocity. And then down here we have negative 0.4 sine 45 equals the Vy plus 0. So that one's pretty easy because it's already done for us. So go ahead, subtract that 0.5 over there. And we end up with a number of negative 0.217. So Vx equals negative 0.217 meters per second, and Vy equals that mess. I don't know if I calculated that number. I did not, of course. Negative 0.4 sine 45. What I want to do is I want to take those two and put them together to find magnitude and direction. So I'll draw my little picture. And so we go negative 0.217, and then we go our negative 0.4 sine 45, and I want to find magnitude and that direction, which in my case will be south of west here. All right, so I'm going to use the Pythagorean theorem. I should get a value of 0.357 meters per second at, so then I should find that angle. Using the inverse tangent, I get 52.5 degrees, and that is south of west. Just to be certain we're on the right page here, 0.217 squared plus 0.4 sine 45 squared, square rooted, gave me the magnitude, and then the inverse tangent of 0.4 sine 45 divided by 0.217 gave me the angle there.